Hey everyone, Lucky Arduino here. Today I'll be showcasing a distance sensor project using, of course, the distance sensor and an LCD display. Let's get into it. Alright, so how does this work? Well, this LCD display takes input from the distance sensor and converts it into inches and centimeters. Just because of limitations from the smaller distance sensor, the maximum distance is about what the LCD display is displaying right now. It looks quite complicated, but really it's quite simple once we look at the code and if you understand how these work. Let's go over that right now. So we've already seen how the LCD display works in a short on my channel, so go ahead and check that out if you want more info. But I wanted to talk about the distance sensor here. So here we have VCC, which is 5 volts. Here we have ground, which is ground, and then we have trig and echo. So basically, how this sensor works is it sends out an ultrasonic trigger pulse to some distance away, like a hand or some blocking distance. Then that sound bounces back, and the echo is what checks the sound that's coming back through these mesh sensors. And then how it calculates it is it uses the travel time between the trigger and the echo to show how much distance it is. And then we can use that travel time to calculate distance in inches and centimeters. And right now it's negative just because the distance sensor isn't connected, but that's basically how a distance sensor works. Yes, so this sensor has a lot of applications, especially if you've ever been in a self-driving car like Tesla. They're able to use a lot of distance sensors, ultrasonic, infrared, many different types to determine where something is in relation to your position, right? And this type of information is very relevant in today's society, and it definitely helps to have a basic understanding of how sensors such as this work so that we can have a better understanding of the technological world around us. Alright, let's go over some of the code for this project. Here we have the trigger pin and the echo pin for the ultrasonic sensor. This is used in different ways for input and output. We'll show that a little bit later. Then we have travel time. This is the distance between the trigger send out and the echo input. Then we have inches and centimeters for the calculations later. Here we have the LCD display code with the different pins for the different inputs and outputs. Here just some code from a class to enable the LCD with a specific name, LCD, of course. Then we have our void setup, which happens once. We have our trigger to set it output and echo as input, which makes sense. You're sending the trigger pulse out and you're receiving it from the echo, and then you calculate the travel time from that. And then we just start the LCD display. Yeah, here is where we're actually sending the trigger thing out. So here we have it set as low, then we delay in microseconds 10. So this is very, very fast. Then we set a really short trigger high to send the pulse out, and then we turn it low again, right? So this has to be very short so that the echo does not pick up surrounding sounds and ultrasonic discrepancies. Then we have, this is the travel time calculation using an inbuilt function of the distance sensor called pulse in. Then we just delay to make sure that the travel time is spaced out, and so that we can calculate the distance with a delay of 500 milliseconds, which is exactly half of a second. Here we do our calculations for inches and centimeters. We use travel time to calculate inches, and then we calculate centimeters from inches. Here we set the cursor for the LCD display. We have some barriers to prevent the LCD display looking a little weird. So if we didn't have these barriers covering the squares, some of the squares would actually be shaded completely black while the numbers were showing up, just because of how the changing sizes of the numbers work. So if you were to have a number like 100, it would take up all of the LCD display, whereas if you had a number like 2, it would leave 2 squares behind because you're using 2 less places on the LCD display. So it would result in 2 squares being entirely black, which looks a little bit weird. So I decided to cover it up with barriers. Then you have inches and some more barriers to ensure that there's no weirdness going on. Then we go to the next line, so a same starting point but different row, and then we do centimeters. And so as you can see, it's very simple code, really. You just need to know the calculations for inches from travel time, and then centimeters you can calculate from inches. Then you just print it out to the LCD display. And that's basically all of this project. Alright, once again guys, thank you so much for watching this video. Check out the shorts portion of my channel where you can get more info on all of these components. For example, the potentiometer, it's used for the LCD display, and it's also a component on its own. So check out the shorts portion to see how these things work, along with this video where I explain a little bit more in depth. And in our next videos, we'll be using more complicated components, so stay tuned for that. And thank you guys so much once again. See you in the next one.